Okay, good morning. Today we discuss about statistics basics. So in our last week's session, I discussed something a little about the statistics. What is the purpose of the statistics? So main purpose of the statistics to analyze data and to perform predictions and forecasting. So let's talk about these predictions and forecasting. A simple difference prediction based on some input variables. You are going to estimate other target variable value. Example, simply I write the same statement about it. Based on some input variables, I mean variable values, estimating value of target variable. So such kind of work simply called as predictions. Example, based on age, I want to predict your weight. Or based on weight and height and of your age, I want to estimate your cholesterol value or PP value. Okay, such kind of things. That means here some of the input variables and some of other things are target variables. So those things simply called as predictions. And if you talk about the forecasting, input variable same, target variable same, but based on the past values of an input variable, you are going to estimate value, future value of the same variable. So you can technically write like this: forecasting means based on past timeline of data. Based on past timeline of data, estimate future value of same variable. Okay. So examples for these predictions, there are different statistical models are there. The example models of these are used for these predictions. The regression algorithms. Okay. Example, linear regression, nonlinear regression, and logistic regression. Such things, such statistical models are used for the predictions. Similarly, for the forecasting, we have different other types. Very fundamental example, time series analysis to do the forecasting. So as part of this time series analysis, we have different models, different statistical models like auto regression, REM algorithm. Okay, these are different other things are there. So finally, the first three models like linear, non-linear, and logistic. These things are used for the predictions, and remaining models are used for forecasting. But how you can define the statistics is simply the statistics is a scientific approach to data analysis, predictions, forecasting. So what exactly the meaning of scientific approach? Already in last session we discussed. I just brief it. The scientific approach means so any conclusion met with some statistical or mathematical measurement. Mathematical measurement. Example, I want to find out dependency between two variables. Correlation we are applying. Suppose correlation of variable 1 and variable 2. If the result is 0.98, you can conclude like there is strong positive relation. Because the value is positive at the circle, the value is greater than 0.5. So with how much force variable 1 value increases, with same force, the variable 2 value will be increased. That is the meaning of this positive relation. So here we are concluding this statement not just by seeing the data, just by seeing this measurement value, the correlation value. So that is the meaning of scientific approach. Okay. Just one example, temperature and your ice cream sales. So general relation is what? As temperature is increasing, ice cream sales will also be increasing. Temperature decreases means definitely ice cream sales will also be decreasing. So such kind of things, we are collecting some data of different events of temperature. At that temperature, how much sales recorded. By collecting that data, after that you are applying correlation. By seeing this measurement value, the correlation value, you are understanding, you are interpreting. There is a positive dependency between two variables. Similarly, if you apply correlation between some other different variables, or else from share market prices, I am taking IBM share prices and Infinity share prices. If I got the relation like this, minus 0.73, our understanding is now the value is less than 0, there is a negative dependency. That means whenever IBM value is increasing, Infosys share value getting decreased. Or if one decreases, another one will be increasing. Such kind of dependency you are understanding by seeing this less than 0. That means minus 0.7. Okay. So this is the meaning of this scientific approach. Any conclusion you want to make? First of all, you have to apply proper statistical instrument. By seeing that measurement value, you have to interpret the data. So this is not general analysis, this is called scientific analysis. Got it? Now let's enter into the statistical part. This is just a overview, what is the purpose of the statistics. Actually, two types of analysis will be there in the statistics. Number one, univariate analysis. Second, multivariate analysis. Of course, when you step into this machine learning, you don't use this terminology. The terminology we will be using in a different step. But before going into the machine learning, first we need to understand some basic mathematical techniques and statistical techniques within the statistics. Okay. So univariate analysis and multivariate analysis. There are two types of analysis techniques. What is the meaning of this one? If you talk about first one, which is univariate analysis. This is analysis over single variable. That means the statistical instrument will be applied at a time on one variable. Statistical instrument. Maybe mean or mode or median or quartiles, whatever it may be. Okay. So analysis for single variable. At a time, your statistical function or instrument will be applied on at a time on a single variable. Statistical instrument at a time applied on single variable. Example, you are collecting data of some share prices. Let's say IBM shares. I'm talking about prices. And also one more variable I have, infusions. Applying that mean. Mean is one of the statistical functions. That means statistical instrument. Mean separately I am applying on IBM. Suppose I got result like this, 70. Same mean I am separately applying on infusions. Think that you have some 10 days data or 20 days data of the share prices. You collected that data and separately you are applying mean on IBM, mean on Infi. Suppose here I got 90. Got it. Now our understanding, when compared with IBM, Infi is giving more returns. That means approximately, if I invest into the Infi, most of the cases my returns will be 90%. On that way, some rough estimation you can do by using any of the statistical instrument. That means most of Infi shares returns are close to 90, maybe little less than to the 90 or greater than to the 90. It can be affiliated. But it is giving you some rough estimation. So here, mean is statistical instrument, but in the first shot, it applied on one variable. In the second shot, it applied on second variable. So that is the meaning of this statement. Statistical instrument at a time applied on a single variable. Got it? Come to this. I'm going to talk about multivariate analysis. Where analysis over combination of variables. Analysis over combination of variables. Here combination means at a time on multiple variables. That means statistical instrument. Instrument of function at a time applied on combination of variables. Combination of more than one variable. So for this example, I already considered the correlation function. Correlation of temperature and over sales. Now it is not applied in a single, at a time applied on multiple. Similarly, linear regression. The linear regression equation is like this. Y equal to A plus Bx. So forget about what is A, what is B. Simply A is intercept here. Here X is input variable. Y is target variable. That means output variable. So based on X, we are going to predict Y. So for that in linear regression, first we will construct a relationship between A and B. Between X and Y, I'm sorry. Here A is intercept. Statistically intercept. In machine learning, we call that one as bias. Okay? So before stepping into machine learning, we need some of the terminology of these things. A is intercept and B is slope here. Got it. Now this model directly applied on two variables. Okay? At a time applied on two variables. Once you apply this one, you will find out A value and B value. Then once you know A and B, then if you know X value, you can do prediction of Y value. For example, I got A value like this. A value 10. How to compute in the coming sessions we will be seeing. And B equal to suppose I got 30. Now what is our equation as per this one? Y equal to A plus Bx is our equation. Now I find out A and B value. Now y equal to 10 plus 30x. Now, if I know x, I can estimate value of y. This is simply called as a prediction. Got it. So that is the difference between univariate analysis and multivariate analysis. And what techniques will come into univariate and what other techniques will come into multivariate. Multivariate. We just list out some of the models, regular used models. The univariate analysis, what you will say is you'll find out number one measure of central kernels. Simply called as MCT. Within this, mean will be the mean means average, mode, median. So all these things we have learned at some of basic school mathematics level. Maybe at the 9th standard, at 10th standard, even from 8th standard also these kind of things we have worked with that. And still other things are there, like dispersions. The dispersions like range, variance, standard deviation. Okay. You take any instrument, maybe mean or mode or median or range, variance, standard deviation. Everything will be applied at a time on a single variable. Okay. Of course, separately you are applying on one variable. If you have another variable, again separately you are applying the same function on other variable. After that, you are comparing the results and you are understanding the pattern between the variables. Got it. So this is called simply univariate analysis. Similarly, if you step into this multivariate, what other techniques will come into this one is covariance and correlation, linear regression, nonlinear regression, logistic regression, and time series analysis. All these things will come under multivariate. So this knowledge is your prerequisite to step into machine learning. So that's why before step into this machine learning, we try to understand each and every one and then how to implement that into on the system by using R language or SAS language or SAS software or even Python. Python is very good, efficient functions are available within the Python, especially for the statistics or machine learning or you take any AI related modules. Python has predefined libraries, that is open source predefined libraries to implement all these things. Okay, I'm coming to this univariate analysis first. Among them, I'm going to talk about MCT. MCT means measure of central kernels. You have three techniques here. Actually, these are all aggregated functions. But we have many aggregation functions like sum, average, maximum, minimum. Okay, even count. In SQL, generally we use a lot of aggregation functions. But every aggregation function is not part of MCT. The MCT main purpose is explain about a variable with a single value. About a variable, I mean performance. Explain about a variable performance with a single value. Mean median. So these three things are considered as density. But there are other aggregation functions such as sum, average. It's not average. Average means mean already listed as density. Sum, count, maximum, minimum. These are rejected from density list. What is the reason? First of all, you have to understand. Because density purpose is what explain about a variable performance with a single value. But sum, count, maximum, minimum, they cannot independently explain about the performance. About these examples, I am taking some cricket runs. To make it easy understanding, the general example I am taking. I am talking about sum of Sachin. That means Sachin cricket score, runs score. I got a value 10,000. I collected all the data of Sachin historical cricket events. I collected the runs and I applied the sum function. So here 10,000 is my value. But the 10,000, just by seeing that 10,000, you cannot estimate the performance of the Sachin. Example, Sachin total score 10,000 in 9,000 matches. If I say like this, on average, not even 2 runs per match. That means independently this 10,000 cannot explain you the performance. But 10,000 is matter along with in how many matches he gave that 10,000. Then it is giving you some basic understanding about the Sachin. So that's why the sum is resulted from this. And let's talk about the count. For example, the count of interviews. Suppose a person attended interviews, but his result is 97. Attending 97 interviews is not a matter. In how many interviews he got succeeded, that is a matter. So independently, this count is also not able to explain the performance. And let's come to the max function. I am saying that max of Ganguly runs in the cricket. I got a value 180. 180 seems to be a biggest value. It may be good score, but if he played 100 matches, only in one match he might be giving 180 score. Remaining matches he might be playing dirty. Very badly he might be playing. So max also resulted from this. Max is not at all a performance measurement here. Definitely, if max is not a performance measurement, definitely minimum also. If I take minimum of Sachin, suppose I got 0 score. Maybe in 1 or 2 matches he might be duck out, but in remaining matches he might be playing very well. Just by seeing this max or minimum, you cannot estimate a person's performance or a variable's performance. That's why these values, the other aggregation functions, like sum, count, maximum, minimum, okay, those have been rejected from MCT list. Because MCT should have a quality, it should be able to explain about a variable performance. That with a single value. But when you talk about average, mean means average, mean of Sachin, I got score of 60. Mean of Ganguly, I got score of 30. Now, I can do some rough prediction, rough understanding about the Sachin or Ganguly. What is my interpretation about the Sachin here? Sachin average 60 means in most of the matches his score is nearer to 60. Of course, in some match duck out, in some match he might be giving 110 or 100 score. But some rough estimation about the Sachin is in most of the matches his score is nearer to 60. So tomorrow is the next match of the Sachin means you have some rough estimation. The score might be 55 to that should be in between 55 to 65 or 50 to 70. On the some rough estimation it is giving you. So mean is good able to explain about variable performance. Similar to that mode and median also can explain. That's why mean, mode, median, triple M simply. These are considered as 1CT. Now let's understand how we can take help of these three techniques to analyze a variable. I'm going to talk about mean first. Mean means average. The average interpretation is like this. Most of values of a variable is close to mean value. I'm not saying that all values, majority of the values. Okay, most of values are close to this variable, this mean value. There are three types of means. In our basic school level mathematics, we have learned all these things. But now, how to compute that is not important to you. When to use what type of mean you should be. Okay, but I give you the formula and how to compute also we will be discussing. But when to use what type of mean we have to understand. We have three types. One is arithmetic mean. Second, geometric mean. Third, harmonic. In this way, we have three types of means. Got it. What is the purpose of each and every mean? When to use what mean? We will be learning now. So first, how to compute? What is the mathematical formula of this things? We will see. And we have to take help of the paint. The formula you will see like this. Arithmetic mean. Simply in short time, I am saying it as AM. If you see the formula, you will see this shape. Sigma xi divided by n. Simply as for programming, you can see like this. Sum of x divided by len of x. That is number of elements in the text. Sum of x divided by len of x. This is simple average, normal average. Arithmetic means is a simple average. For example, x has three values. X is a variable which has three values. First value 10, next value 20, next value 30. Think that only three values. Now what is the AM value? AM equal to sum divided by number of elements. Sum is 60 here. Number of elements 3. Total result 20. 20 is the average. Got it. This is simple arithmetic. Come to this geometric, second one. The geometric mean formula is like this. Is the nth root of is the nth root of x1 into x2 x1 means first value, x2 means second value of x, into x3 up to xn. That means nth root of multiplication of all values. Let's talk about same value. X is variable. Variable has 10, 20, 30 values. Now what is the geometric mean? The geometric mean is equal to nth root 10 into 20 into 30. 10 to the power of 1 by 3. Cubic root. Cubic root means to the power of 1 by 3. Like this. That means cubic root 10 into 20, 200, 200 into 30, 6,000. Cubic root of 6,000. That is geometry. The next type of mean is harmonic mean. How to compute this we'll see. Harmonic mean. HM equal, simply the short name HM equal 1 divided by, I will write with the paint, n divided by 1 by x1 plus 1 by x2 up to so on 1 by xn. It's not n, it's 1. That means previously if you take 10 values, 1 by 10 plus 1 by 20 plus 1 by 30. On that way you can find out this one. That means 1 by 10 means 0.1, 1 by 1 by 20 means 0.2, like that. Okay. Now observe here. How to compute the mathematical formula is not important. A simple formulas, already you know these formulas in our basic mathematics of school education. But when you have to use what type of mean? Okay. There is a relationship, first of all. First we see the relationship, and after that we go for when to use what. AM value always greater than GM value. GM value is always greater than HM value. Got it? Or else you can reverse it. HM is less than GM. Geometric mean. Geometric mean value definitely less than arithmetic mean. Okay. Now let's come to when to use what type of mean. This clarity is must for us. Because each type of mean is best fit at one particular situation. Suppose at situation number 1, if arithmetic mean is good, if you apply other mean, your analysis will be failed. So in a right situation, right type of mean should be used. I go with the different examples for this. By seeing these examples, you can understand when to use what type of mean. Observe here. I'm going to compare two person units. Under this, person 1, think of that is you, your weight is 76. And person 2, that is me, the weight is 76.900 grams. That is kg and grams. Now let's talk about only 400 grams or 500 grams. Now question is, Who is fat? This is my question. I'm not asking who has high weight. My question is not one. I want essence of that. Who is fatty? Just by seeing his weight, you cannot say the person too as fatty. Because here 76 is the weight. Or else you just consider this example. 76.300 is the weight. Here 76.200 500 is the weight. Got it? Just because of 200 grams extra weight, you cannot say the person 2 is fatty and person 1 is thin. Got it? So here, between these two person weights, whatever the fraction value you have, that is decimal value you have, that is neglectable. Neglectable. You are not considering that one in terms of these person weights. That means there is no big weightage for that. Got it? So whenever, wherever the decimal values, that means the fraction values are neglectable, then you can use arithmetic. Okay, I write that as a same statement here. Where decimals simply talking about the fractions of neglectable, then you can use arithmetic. Understood. And come to this one. One more statement here. You see this, let's say talk about as an example number one. I'm comparing two person weights. Example two. Compare two gold ornament weights. Gold one ornament one. Gold two ornament two. I'm talking about their weights. Let's say 20 gram point 123 12. Zero. That is ornament weight number one. Second, same thing 20 point. Here I have 45. Zero. Now in this case, you cannot neglect that fraction. Of course, difference is less. Difference is a 0.33, 0.33. But 0.33 will cost a lot. Got it? So in this case, you cannot neglect. You cannot neglect decimal values. That means fraction values. So then you have to use geometric method. Consider this example. If decimals, that means fractions, are important, I may not neglect. So in the first case, first example, you are not considering those, giving some importance to those decimal values. But here, the fraction is important. Okay, then use geometric method. Got it. The geometric formula already I have given. It's an input of multiplication of all the values. Got it. Similarly, one more example. You just think about it. Comparing before yesterday temperature and today temperature. So yesterday temperature is like this. 32.4 degree of Celsius. And today 30.6 degrees Celsius. Difference is there, 0.4, 0.6. The difference is 0.2 only. Just because of extra zero point 0.2 today, 0.2 extra of temperature today, we don't feel that today is very sunny. The effect of yesterday temperature, today temperature on human, almost same. Understand? So here, I will use arithmetic mean because the fraction part is neglectable. But same thing, I am going to compare. I am going to talk about rainfall. Rainfall in centimeters. For example, the rainfall is like this. The measurement is like this, 4.6 cm. In another day, that is 4.9 cm. There is a huge difference between zero point 0.6 and point. At air temperature, I can neglect, but here at rainfall, there is a huge difference between the 0.6 and 0.9. Here we cannot neglect. So in this case, we have to use geometry. Understand? Geometry tool is important here. Come to the other example. I am going to talk about harmonic mean. There is another name for this, scientific mean. Mostly used in scientific applications, that's why they call it as scientific mean. There are two situations for this harmonic mean. Number one, outliers. Existed in data. What is that outlier? I will discuss. Second situation, sub-fractions are also important. That means minute fractions. Also very important. So in these two situations, you have to use harmonic mean. So what is the meaning of first example, first situation, second situation? We try to understand. I am coming to the first point, outliers existed. Outliers existed in it. Suppose case 1 I am taking, observe this example. I am going to talk about only Sachin, runs only. Suppose his runs are like this, 60, 70, 80. Some easy calculated values I am taking. 10, 20, 30. How much think that score is that? Think that only average. Only he played 3 matches. I am applying normal mean. That is AM I am applying. So total 60, 60 by 3, 20. Now the interpretation is like this. Most of his scores close to 20. Maybe little plus to 20, little minus to 20. So if we consider this example, of course, then 10 is 10 feet distance to 20. 30 is also 10 units distance to 20. Let's take another example. I am taking 60, 70, 80. Some of the scores are like this. Now what is the total? 210. 210 means what? Average 7. The interpretation, most of Sachin's scores are close to 7. Just try to validate this. 16, of course, close to 70. The second equal to 70. And third one, this idea is close to 7. Now your interpretation is wrong, not wrong. Tomorrow is the next match by the Sachin. You have some estimation. Okay, if you start playing that, the score might be nearer to 70. On the way, you can estimate something about the Sachin. But observe the case number 2. I'm going to involve some value here. Think that Sachin played four matches. Of runs only I am taking 60. Next match 70. And next match 80. Next match 290. What is the total now? 290 plus 210. 500. Total number of matches 4. 500 divided by 4 average now. If I apply arithmetic mean, I got 125. General interpretation is what? Most of scores, most of values are close to 125. But test it now. The 60 is not close. 70 not close. 80 not close. And 290 not close. No value is close to the 125. Got it. So in the first case, your estimation is correct, but in the second case, your estimation is getting failed. What is the reason? Generally, such values are here 60 to 80. This is a regular behavior of the Sachin. But on the today, unexpectedly or uneventually, the 290, he gave 290 score. But that is not his regular behavior. This is irregular value for the Sachin. This is called outlier. If outliers existed in data, the mean is giving you wrong. Sorry, the mean is giving you wrong interpretation. Understand? I repeat the statement. If outliers existed in data, the regular mean is giving wrong interpretation. So that definitely our analysis or estimations will be failed. So in that case, if outliers existed in data, you have to go with harmonic mean. Okay. So what is the value? Because here there is a huge weightage by this. There is a huge weightage by this. This 290 is disturbing entire data. Got it? That's why here your estimation is failing. Your estimation is most of Sachin's score is near to 125, but in fact no value is close to 125. This wrong interpretation because of one outlier, that is 290. There is high value which is irregular value. Now we need to leverage that value. That means we need to weak that value. To weak that, if I consider 1 divided by 60 plus 1 divided by 70 plus 1 divided by 80 plus 1 divided by 290, which is lowest value. Previously 290 is very bigger value. Now 1 by 290 very low value. So this harmonic means is a technique to weaken, to make weak of outlier value. Got it? So finally it is leveraging the values. So that is what the meaning of outlier. If outliers existed in data, you have to use harmonic for better results, better interpretations. Got it? And one more case here, the subfractions also very important. What is the meaning of the second point? If subfractions also important, that means where values are not roundable. Generally in SQLs or in our programming languages, we are applying a round function to take first two digits after the decimal like that. But in lot many cases, the fractions are not roundable. You should not round them. If you round them, the meaning will be changing. Okay, what are those examples? I will show you. For example, let's talk about chemical compound weights. Okay, suppose chemical one, compound one, its weight is 0.452 4. 1, 2, 3, 4, 6, 7, 8, 9 into 10 to the power of minus 6 like this. Into 10 to the power of, here in notepad, power value you cannot write, that's why I am using this cap symbol, 10 to the power of minus 60. That is chemical compound weight number 1. And come to the compound 2 weight. Here the values are like this, 0.452, 3, 8, 9, 2, 3, 1. Some value can be like this. 7 into 10 to the power of minus 60 mg. Now over here, if you start rounding, round the value to after decimal, try to round the values to the four values. Compound one is like this, 0.4524. I just rounded. And compound number two, round to the four values after decimal, 0.452. Next value is above 5. That's why it will become 4. Now both compounds seem to be same weight. But in fact, as per chemical compounds, there is a huge difference between weights of these two compounds. If you round them, both seems to be same. Even our human brain cannot recognize such kind of less weights because our brain has a behavior of rounding the values. But in such cases, you cannot neglect after 4 decimals or after 5 decimals. You cannot neglect them. That is very important. That is the meaning. Where minute fractions are also important to you, then you have to go with harmonic. Understand? So in this way, different things. I just repeat. When to use what? When to use what type of mean. The fractions are not important. That is during the comparisons. Then you can use automatically. The fractions are not neglectable. That is important. then you can use G. And two situations for HF. Number one, if outliers existed in it. But how you know outlier available in the data or not? There are different techniques to find out outliers. Those techniques also you will be learning. Okay? If outliers existed in it, this is one situation. If existed, definitely they are giving wrong interpretations. And second thing, minute fractions, that means sub fractions, also very important. That means value is not roundable. In these two cases, you can use. Okay, this is simple clarification. Want to use what type of mean? Okay. Now, how we can take help of mean during comparative analysis? This point we will understand. Just after completion of explaining this, then we will take a break for 10 minutes. Then we will restart the thing. How we can take help of mean during comparative analysis? That means you are going to compare two variables. Which variable performance is good, on that way you are trying to understand. Example, same cricket example I am taking. You have different players. Among two players, I want to compare. Among Sachin and Ganguly, who is best as per runs? I am talking about only runs, not about remaining attributes. Suppose you have data of 100 matches of Sachin, 100 matches of scores of Ganguly. So in this case, who is good, who is best? How we can say? Simply you can apply mean of Sachin, and separately mean you are applying on Ganguly. Of course, when you talk about these runs, the decimal values, fractions are not important. That's why directly you can apply arithmetic mean only. Okay, already I gave that clarity when to use what type of mean. But on a variable number one, if you are applying arithmetic mean, second variable also you should apply same arithmetic mean while you are comparing two variables. Suppose I got a value 70 here. I got a value 30 here. Now which variable is best? How you can take the higher value of the mean generally good. Because when you talk about runs, high runs is good score. That's why high mean value you have to select. Okay. But there are some cases we will select less mean value. That also, so when to select high value, when to select low value. A simple clarity here. If high value is priority, select high mean value. Similarly, also some cases if less value is priority, select less mean value. So for the second thing, example, mean of White balls. I'm talking about white balls. Mean of bowler 1. 5 white balls. Mean of bowler 2. 17 white balls. An average of all the matches. Now, when you talk about number of white balls, same in the cricket, less value priority or high value priority. Just think. Definitely less value. Okay, when you talk about negative, less negative is important. When you talk about positive, high positive is important. So here, less mean variable value. That means who is best bowler as per number of white balls means bowler 1 is best because you are giving priority for the less value. That's why less mean variable you are going to select. In the first case, as per the above score, not based on I'm a fan of Sachin, I'm a fan of Ganguly, not based on that one. Just by seeing the measurement scores, we are saying that Sachin is best in the first example. In the second example, bowler 1 is best because of less value priority. On that way I can compare. But some cases you cannot take the decision. What is that situation is? I'm going to talk about mean of Sachin. I got 60, 70. Mean of Ganguly. Suppose I got 70. Now who is best? We cannot conclude this. Just because of one value extra, you cannot say Ganguly is best. Or else Ganguly score is 69. Just because of one score down, you cannot conclude like Ganguly is bad player. That means when you are not able to take the decision is if two variables means are equal or close together, we cannot take the decision. I repeat that point. If two variables means are equal or close together, then we cannot conclude this. What is the solution for this? Then you need to go and check with its mode. Directly you are not coming to the mode. First you are coming to mean. If two means are equal or close, then you are going to compare with mode. Okay, what is that mode and how you can take help of mode and how you can solve this problem we will discuss. All of you, let's take a break of 15 minutes. Okay, 15 minutes break. Then we will reset. Now the time is 11:09. Okay, make it as 11:10, 20:25. By 11:25, we will be back and we continue the discussion. In tomorrow class, like how to implement all these statistical functions by using Python language, we will see. Okay. So about tomorrow's information again, I will announce into the groups. They'll just follow that one. Again, the link, if any link changes, that link I will post into the groups. Thank you very much.